Good morning. My name is Frank Seta, Frank Seta Associates. We are exterior wall consultant in New York, and basically our function has been the entire envelope and facade. I wanted to thank first GPD and ESW for coordinating this invitation. It's been a great experience for the last 3 days. I was asked for talking about the glass, but at one point I said there are plenty of specialists that they're going to talk about the glass. So I decided to talk about what we call it 4-inch limit stop and failure of windows in high-rise buildings. I would like to note that if you remember this picture, later on we're going to talk about it. This is a project that they had 3 failures of window in half an hour. One window fell off the building, and they were lucky that it landed on the next door building. 2 of them, as you see, this is one on the west elevation, stuck in the elevation. It's that simple. So let's talk about limit stop. Limit stop basically is a device, a stainless steel device that holds the window in the right position. I brought a sample here, which is made of stainless steel. As you see the function, you could open it, it locks, and the second motion, it closes. So at this point, I would like to talk about why we need limit stop. And if you look at this picture, in the old days, you could see that the window guards were used, and it was successful. However, after coming up with the new generation of the windows, this guard was not be able to function. And that's why limit stop came out in the picture. In general, limit stop installs in the window jamb and holds the window in a position that this dimension is supposed to be around 4.5 inch. The reason for that is if a kid wants to pass the window, it will be stopped by this limit. Now, as you know, there are times that we cannot control the kids, and for that reason, in 1976, in New York City, they came up with the idea of any apartment that has 10-year child or younger should have this guard or limit stop. And back in 1976, the average was 217 cases. After passing this law, eventually turned to 3. So it was a great success, and one of the reasons for that is by enforcing this law, they were able to not only to hold the window in the right position, but avoid a lot of accidents. New York City Department was the main force behind this, behind this application, and Department of Health is actually enforced that. If me as a supplier wants to apply this or install this, I have to go to a vigorous test, and I would get a number on my device that clearly shows it's a legit product. To test this product, we open the window and try to bypass a 5-inch ball. Obviously, if it cannot be passed, it's a pass. And the next test is, if you look at this number, 150-pound pressure. Now, remember that number because we're going to talk about it. The window has to withstand 150 pounds. And if it passes those two tests, you have a legitimate parts and piece that you can use on your window. Then the next step, they found that a lot of people that they wanted to have more air start to open these pieces and parts from window. So the second generation came up with screws, tempered screws that only custodian of the building could open it up. Now, why? What is the problem then? You have several devices around the window, which is lock it, hold it together, stop the opening at 4-inch. Why there is a problem? Recently, in last 2 or 3 years, we faced with several incidents, different buildings, which I would like to talk about it. We talked about this photo before, and this is what happened. In one day, a very windy day, we received a phone call that 3 windows were separating from the facade. One fell off. And when I spoke to the mechanic who was in one of the room, he said first he saw the window start to separate and then violently start to shake, and he saw the actual window which fly away from the facade. Now, you can imagine if that window landed on a main street, what could have happened. I've been involved with cases that for ice and snow, there have been like $40 million lawsuits. So you could imagine if this window falls in somebody's head, what could have happened. The design of the window, as you see here, what's holding it, what we call it is a candy can system. In addition to that, there is a profile that allows the window turn open and stops at this level. We found out in one case that this window was able to jump out of this area, and it would be hung by this piece. And eventually, after a couple of times, it releases and came to the street. In that case, it fell off over a taxi cab windshield. Luckily, nobody got hurt. This is the actual window, as you see, after incident. And as you see, it's completely damaged, and we couldn't even find the limit stop on it. And what happened is basically, first, the limit stop let go, and the only thing which was holding the window, as I mentioned, it was a candy can, which was separated, and at this point, the pressure was so much that this piece let go, and eventually window failed. Now, how to improve this? We started to look at the reason of the failure. First, we noticed that there are some parts in limit stop, there are plastic parts. So my recommendation to you guys as a professional, when you see a plastic, just reject it. Don't ask anything, just reject it, because we've seen over and over issues with that. And at the same time, we could see the design right here was not strong enough to hold the window after failure of limit stop. Let's talk about stack effect. You all know what is the chimney. The chimney effect or stack effect is on a construction, a tall building, especially that is open at the bottom or part of the wall section, and eventually the wind gets inside the building and create the turbulence that nobody expects. This action actually could happen on a brand new building or existing building which has open doors, obviously on the storefront, and as a result of that, air could come through. I'm sure you have walked through a lot of buildings that, especially close to elevators, you could hear the whistle noise, and that's a flow of the air that goes through the building and creates this pressure. So remember that our building, especially the tall one, is constantly under pressure. In wind tunnel test, as you know that positive load or airflow comes from this side, and as a result of that, we call it positive load, it could create a negative load. That we're going to talk about it later on. We designed these buildings based upon what they are telling us as far as positive and negative load on the facade. One thing I've learned for the last 40 years that nobody talks about stack effect. And that's not right, because we have to consider that load in addition to what we are getting from lab test. This is the piece that I wanted to talk about it. We talked about no plastic in hardware. And believe it or not, this keeper was made out of plastic, and we found in one job that it started to crack in very short period of time. In one of our buildings that came to us, and the ownership asked us to help them, when we started to troubleshooting and looking at the drawing, shop drawing, and product data, we found out that, as I showed you in that candy can drawing and so on and so forth, there were a lot of issues that we had to resolve it. Think about this. How many architects are here? 1, 2. Okay. My question from you is, when you go to the lab test, we have basically air, water, structure, and propeller test. Have you tested the water test or air test with open position window? The answer is no. First thing that you go, you lock all the windows, and make sure everything is tight. Then you run a test of air, water, structure, and so on and so forth. But the reality is, you as a consumer, you're living in an apartment, you want fresh air. You open the window, and then you get a phone call. You open a window, you go downstairs, do the shopping. So what happened is, there is another option that we need to test, and we have to think about it, that there are times that the window can be open, left open, and guess what? It will be exposed to the same load that we were talking about it before. Positive or negative load. And that's what happens in a lot of situations. The owner of this building called me and says, not only I want you to reinforce the building facade, I want to make sure even if somebody left the window open, nothing happened. So for that reason, we added another device to the 4-inch limit stop and reinforced that even in the open position, window was able to take the actual load. During different tests, we noticed that the weak part is right here, which I'm going to show you the photos later on, and right here at the hinge. In several incidents, we found out that this handle is riding up and it's separated right here. And actually, in this case, we've seen portion of the device has been twisted, believe it or not, because of the pressure. So in this photo, you could clearly see the chimney that we were talking about. The air flow could easily get into the building from different opening and create that wind effect or chimney effect that we were talking about. Now, in plan view, what we have is a copy of that wind tunnel test, that the wind could come in from this point and create negative and positive load. So at one point it could get inside, and as a result of that, instead of one force, you have combination of the force that comes out after the window or the facade. Again, I've seen in rare projects that the facade is designed for both forces. This is a sample of an in-swing window that it was left open, and after heavy wind, you could see what happened to the glass, completely broken. So what are the responsibility of the 4-inch limit stop? Holding the window in a position around 4 to 4.5 inch. That's the maximum opening size. And again, over and over, we found out that this is the part that it usually let go. And we try to focus on that. And as you see right here, there is a dimple that holds this handle to ride off. And that's what usually happens. There is a plastic part inside of it. So what we did, we added another plate right there to hold this, and we were very successful by doing that and improved a lot as far as the performance of the limit stop. The other issue that we found right here, the bending of the material, by adding more screws, we were able to reinforce this piece, and we found out that the performance of the window when it approaches by positive, negative load it's much, much better. This is a second project that we dealt with. Again, the window let go and fell on a next door building roof. Luckily, nobody got hurt. But as you see, the impact of the window, which fell on the ground, as a result of that, the whole assembly got damaged. And right here, you see that the corner key is still there, but it couldn't keep the jam and seal together, and it's completely open. Now, in this case, which I mentioned, 3 incidents happened. At one point, the project manager was telling me that they got a phone call, one window is loose and it's hanging, dangling from the facade. They rushed there, they're trying to put them together, and then they get a second phone call that this incident happened on another floor. By the time they got there, they found out the window started to dangling in and out and then violently moving out. They were lucky that the window got stuck 90 degrees on the facade. So, but the third call that they got, they called them and they said, we just lost the window. So these are the things that we need to be concerned about when we deal with high-rise buildings, because there are forces that, if you look at the AMA or ASTM, they really don't focus on reality. So we started to experiment by putting the window in front of the propeller, and obviously this was our first try, trying to hold the window by handle and the rope. But when the propeller started to build up pressure, the rope was not a match to hold the window closed. And as you see, it just let go. So our second try was back test. We put a bag behind the window and slowly blow the air inside of it and push the window out. But again, what we got out of it, it was a slow motion of the window being open, and it really didn't mimic what happened, what I call it the snap test, sudden impact that we have experienced on other projects. Okay, we tried this test by having a propeller in the angle, hoping that running the propeller at the angle will open the window and we would see what happens. But our thought, it really didn't work with the reality, because there was so much pressure, as you see, on this window, that no matter what we were actually, I had somebody who was pushing the window out, but the pressure was so much from the angle that kept the window closed all the time. So again, this didn't work neither. As I mentioned before, we tried to improve the limit stop and repeat of what we talked about. Okay, this one worked. And the reason for that is, if you noticed, we had the propeller not only blowing to the front, but blowing in the back, and we created a box in the rear portion of the window. So we built up enough pressure on interior that kept the window open. And we were almost there by doing this test. As you see, there were several steps. Window got open. And this is what we were looking for. Now, as you see, total failure occurred. The reason for that is, if you remember that formula, the positive and negative and built up pressure on interior side, it could create that moment that the window completely pops, and as a result of that, you could see how far this window goes. Obviously, we were not able to create the optimum pressure or gust that you see up in 60-story building, so we didn't see the window starts to coming out like 90 degree, which I showed you photos, but it was enough to prove that even with the lower pressure, you could have a complete failure and pieces and parts that they get dismantled. So we went back to the drawing board and we tried by reinforcing these parts and pieces. And the following test, we found out that we have improved the building, the windows, that we felt comfortable. Yesterday, we had a discussion between the architect and my friends and structural engineer that, or consultant, that what are our responsibilities? As a consultant, I would say we have to show the red flag to the design team, because as you see here, we ended up testing a window that it was 6 foot by 11 foot, one sash. The entire project was designed around this sash. Although we passed the LEW test on this window, passing 4,000 times open and close and so on and so forth. But at the end, ownership decided to abandon this project with this window, and they went with a smaller size. Now, I'm going to tell you, we were lucky and they made the right decision. In my own apartment, I'm living in a 29-story building. And we always keep one of the windows near the kitchen open for fresh air. One night I decided to open a second window for more air coming in, not knowing there is a turbulence outside. I had such a hard time to hold the window on interior. And I had to use my second hand to close the window. Then it came to my mind that what happened if this window was outswing? And I would open it and it just let go. So again, these are the reality that we have to think about it as a designer, as a consultant, as an ownership, as manufacturer, and come up with the design that doesn't expose none of us. And as a consultant, I've always said, if we come up with a solution or objective way to look at it or reject the whole thing, there is a reason behind it. And that's protection for everybody, starting from the developer to designers, CM, and even suppliers. So let's think about it. What do we have to do? After seeing all these cases, what is the right way? What is the wrong way? How far should we go with this process? This is the scenario that I talked about it. You could have a large room, open one window and the other one. And as I mentioned to you, that could happen. And here it's during construction, for instance, you could have a damper that holds the air and minimize the stack effect throughout the building. As I mentioned, a typical wind tunnel test is only showing us the positive and negative load. Nobody tells us about the stack effect throughout the building, during construction and after the construction. I've never seen for the last 40 years that any of these tests take out one or two windows and then show us what is the point pressure on the facade and what we have to deal with later on. And again, the same diagram that shows how the wind goes around, and it could pressurize inside the finished apartment and turn it to a big catastrophe.
You have 5 minutes over.
Pardon me?
You have at least 5 minutes over your time.
Oh, okay. So the final thoughts. As a designer, as a consultant, I think we have a responsibility to come up with a solution that works for the whole team, starting from the developer and builder, construction manager, architect, and at the end, the consultant. We need to think beyond the box and think about additional safety measures that help all of us as a professional. Thank you.
Hi there. Did you like what you just saw? If you did, why not like the video? Drop us a comment below, as well as share the video with others, since GPD is all about sharing. And to receive more videos in future, subscribe and don't forget to click the bell icon for notifications. Ciao.